So today we're going to be talking about everything that has to do with soil and carbon in the Northwest Territories and how these factors change when we convert boreal forest to agriculture. And the reason that I'm going to be here talking about soil is because for the last 6 or 7 years, I've thought about soil, I've processed soil, I've analyzed soil, collected soil. Sometimes I've even been dreaming about soil. I know my parents have been tired of hearing me talk about soil, my friends have been tired of hearing me talk about soil, and I know my girlfriend has definitely been tired of hearing me talk about soil. But as a researcher with the University of Guelph, for the last 6 years up until December, I was working in the southern Northwest Territories, trying to understand what happens to soil when we convert pristine boreal forest to food production sites or agriculture, and how this impacts the long-term health and viability of these soils. But as a researcher and someone who talks about soil so much, I realize there's generally two types of people that exist when you bring soil up to them. The first is what I like to call group ones, and these are people who are genuinely interested or genuinely excited about the concept of soil and everything that it has to offer. And then there's the group twos. Those are people who start to zone out, they go on Facebook, they bring out their phone, and they generally tune out and think, why is this guy about to talk to me for half an hour about soil or dirt in the ground? So in this presentation, I have two main objectives. The first one is to convert some of you group twos over to being group ones. If I can get just one of you to switch from being a group two to a group one and start to care about everything that is amazing about soil, I feel like I'll have done my job today. My second goal is to make sure that I'm not creating a third group of people who are just upset and angry that I've wasted half an hour of their life on this presentation talking about dirt when it's just the most uninteresting thing in the world. But how do you do this? How do you get people to care about soil? How do you make soil interesting? Well, I'm going to start with these super exciting and interesting equations that I'm sure all of you are really interested in learning about. I'm just kidding. We're not going to do that. But we are going to talk about everything that makes soil amazing. And this picture says a lot, and it definitely is eye-catching for a lot of people. And it just shows the diversity, the variability, and the heterogeneity of what soil is and what it looks like across a relatively confined space. So these are all samples from the southern Northwest Territories, from farms and forests, all within a couple community range of each other. And when we talk about soil today, I'm going to be using a few different key terms that I'm going to try and outline for you now. The first is soil organic matter, and this is all the dark stuff that you see in these pictures here. And this comes from animal remains, it comes from plant material, insect debris, anything that consists of organic material that gets deposited into the ground is a constituent of what makes up soil organic matter. The next is soil carbon. And generally we can say that 50% of soil organic matter is soil carbon. But why does soil carbon even matter? Well, when we look at the boreal forest, or this forest ecosystem that stretches all the way across the circumpolar region, we look at an ecosystem that stores more carbon than any other ecosystem on land. And this is important because we want to make sure that this carbon stays in the ground. Because if it gets released from the ground to the atmosphere, that can have really negative consequences for climate change. And then finally, the third term I'm going to talk about is soil fertility. And soil fertility can mean a lot of different things to different people. For a lot of farmers and growers, it can mean things like the texture of the soil or the color of the soil or how it feels between their fingers. But for me as a researcher, when I talk about soil fertility, I'm talking about the nutrients of the soil, the potassium, the nitrogen, the phosphorus, all these things that help to make crops grow. And in this presentation, we're going to talk about soil and how it changes through different land use types. So soil looks different when it's in a pristine area of boreal forest in comparison to when it's in an agricultural or farm site. And both of these are impacted by wildfire. And wildfire can alter soil dynamics in the way soil looks and acts and feels in both forest and agricultural systems. And with the Northwest Territories and much of Canada having their worst wildfire year on record last year in 2023, wildfire is definitely top of mind when looking at the impact of soil and how it will respond to future disturbances. But before we keep talking about soil, let's talk about money. So how do we get more money in our bank account? We accumulate penny by penny, paycheck over paycheck, year after year, and slowly but surely, we start accumulating wealth in our bank account. And this takes time, and it takes effort, and it's a slow process that relies on a lot of things going our way to make sure that this bank account begins to fill up. And much like a bank account, soil takes time and effort and processes to accumulate millimeter by millimeter, year over year. And soil accumulates over thousands, if not tens of thousands of years in a lot of cases. But if I'm going to get nerdy for a second, this slow accumulation allows us to use soils as a time capsule or an archive of these historical stories that tell us what the landscape looked like through time. We can learn about how the landscape was once a wet, marshy area, and then how it transformed into a moss-filled bog, or how it then moved into a forested site, or finally a grassland site. And all the data that's contained in these soils is just this long story that we can use to understand what the ecosystem and the environment look like and how it may respond to future disturbances. And this is all just this interesting historical archive that's right beneath our feet. But like I mentioned, soil and soil carbon accumulate slowly over thousands of years. And when this gets deposited into the ground, this starts to fill up our soil carbon account. And like our bank account, it takes time and it takes a variety of processes happening for this value to start going up. But we've been saving money for a while now. Things are going our way, the economy's good, and this has resulted in our bank account filling up. So we have all this money now, and what are we going to do with it? What allows us to explore all these options that aren't available to us when our bank account is empty. Things like going to concerts or entertainment events, travel, buying bigger houses or fancy cars, or anything that we like to spend our money on. These services are available to us when our bank account is full. And similarly, when our soil carbon account is full, and that amount has been increasing over thousands of years, this allows the ecosystem to provide benefits that we like to call ecosystem services. So things like biodiversity, both below and above ground, the cycling of nutrients for vegetation and crop production, water purification, drainage, and flood control, these are all benefits that are enabled by the accumulation of soil organic matter and soil organic carbon. And these are important to consider when we're thinking about healthy ecosystems and sustainable ecosystems, and we need to think about soil carbon as top of mind when looking at the relationship between below and above ground health. But money can't keep going up forever. There's inherently challenges and obstacles we have to overcome. Things like recessions, taxes, inflation, all of these drive down our bank account and inherently potentially reduce the services or options that are available to us. And just like when these recessions hit, there's disturbances that drive down our soil carbon account. Things like climate change, wildfire, permafrost thaw, erosion, flooding. These are all things that cause carbon to move from the soil to the atmosphere, and this reduces the amount of carbon that's stored in the soil. But we're resilient, we're creative, we're innovative, and when we see our bank account going down, we're not just going to sit back and let that happen. We're going to start to take action. So what are we going to do? We're going to start our own business. But before our business can take off, there's a steep learning curve. There's startup costs. There's all kinds of trial and error that has to happen for our business to start making a profit. And because of this, we can initially actually lose money from starting this business as well. And we can look at agriculture in the Northwest Territories or in the Boreal Forest in general as a similar kind of process. Agriculture has all these amazing benefits like food security, food sovereignty, and providing nutritious sources of food. But there's also the potential for it to be this new novel disturbance in boreal soils, which can cause this initial drawdown of carbon that is ultimately released into the atmosphere. But what is the extent of this carbon loss that's caused by agriculture, and what do we know about it in general? So when I was a researcher, this was one of the first questions I wanted to answer, which was how does food production in the boreal forest impact soil carbon? And to answer this question, we collected a lot of soil over a 4-year time span. So we worked with 2 community partners in the Northwest Territories, which were Kakisa and Enterprise. We collected over 1,500 pounds of soil, and let me tell you, when you start putting that soil in coolers, it costs a lot of money and you make a lot of people unhappy when you start emptying the shelves of local stores of their coolers. We also worked with 7 northern food producers or northern farmers, and we shared back 10 data reports with community members and farmers about the soil we collected. And so to answer this question about carbon, here's a graph that shows one of the main takeaways from the research that we did. So on the vertical axis, we have the soil carbon, and on the horizontal axis, we have the time since cultivation, where time 0 represents these boreal forest soils, and time 30 represents 30 years after agriculture has taken place. And we have 2 lines here that show a global data set that represent these trends in a global context around the boreal forest, and then we have data specifically from the soil I collected in the Northwest Territories. And what we're seeing is that in the first 30 years after cultivation occurs in the boreal forest, we're seeing between a 66 and 70% decline in soil carbon. And that is significant. That's a lot of carbon that's leaving the soil and moving into the atmosphere. And if this happens on a large scale, this could have serious implications for climate change, which is why any future agricultural management decisions or land use planning need to keep soil carbon top of mind when thinking about these decisions going forward. So let's get back to our business now. We've been working on it for a while, working hard, and we've learned new skills like teamwork, marketing, and leadership. We've made mistakes, we've grown, we've brought on external help, and all of this has led to us reaping the rewards of our hard work, with our bank account starting to go up thanks to the new profits from our business. And agriculture has the potential to do something similar for boreal soils or Northwest Territory soils. We can explore new soil management techniques and agricultural practices that are novel in places like northern climates. Things like different forms of composting, manure, cover cropping, biochar, anything that adds organic material to the soil, these can all have positive benefits for putting carbon back in the soil or potentially reducing the amount of carbon that's lost from the soil originally. So this could all lead to our soil carbon account going back up, even if there's an initial period of it going down when agriculture first occurs. But some of these agriculture management practices, while they may be beneficial for carbon, they also need to be beneficial for producing sustainable crop yields. So we need to think about these relationships between fertility and carbon in the context of agriculture management. And this leads to 2 of my next research questions that I aim to look at when I was doing the research in the Northwest Territories. So the first is, what relationships exist between healthy or fertile soils and soil carbon? And the next is, how do we achieve carbon-rich and fertile soils? So using that same 100 or 1,500 pounds of soil that we collected from the Southern Northwest Territories, we explored this relationship between carbon and soil fertility. And just as a reminder, when I say soil fertility, I'm talking about nutrients like nitrogen, phosphorus, and potassium, or all these things that help plants to grow. So this graph here on the vertical axis, once again, we have soil carbon, and on the horizontal axis, we have soil fertility. And there's 2 different relationships I want to highlight here. The first is in blue, or these pre-cultivation soils, or these are soils that are still boreal forest and haven't been converted to agriculture. And what we see here is that areas with less carbon are more suitable for food production. And this has a lot of important implications for land management planning, which I'll touch on in a minute. The next relationship here is these post-cultivation sites. So these are sites that are currently being farmed, and what we see here is that we need to put carbon back into the soil to increase the fertility or the nutrients of that soil. So I mentioned we saw this inverse relationship between carbon and fertility in these uncultivated soils. And we wanted to make sure we could make a tool that communities and land managers could use to hopefully identify areas of low carbon and high fertility so we could limit some of this carbon loss if these areas are to be utilized for agriculture. So on this map, all of the colored areas are areas of lower soil carbon, or areas that were below our average values. All the areas in white are areas of higher soil carbon, or areas we'd like to avoid for cultivating. And then in terms of fertility, the size of the dots represents how fertile the soils are, with a larger dot indicating more fertile or nutrient-rich soils. And this is just a first example of a type of product that we can use to start to take a precision agriculture approach in these carbon-rich environments. We also began to assess how effective some of the commonly used agriculture management practices that some of the farmers we worked with were using, how effective these were for carbon and fertility in these boreal soils. And I just wanted to highlight one of these commonly used management practices in this presentation today, and that's tilling. So this graph here once again shows soil carbon on the vertical axis, and it shows whether or not the sites were tilled on the horizontal axis. And what we're seeing is that sites where no-till agriculture was happening had significantly more carbon than sites that were tilled. But this is just some example preliminary data. There needs to be more robust investigation as to which agriculture management practices work in the north for both carbon and fertility. And because of the unique, complex, and different conditions that exist in northern boreal soils in comparison to temperate or tropical southern soils, we need to develop these management practices specifically for the north, for the unique cultures and environments that exist here. So let's just take a pause and take a deep breath and think about and summarize what we just talked about. So the first thing is that soil matters. Soil underpins so much of what makes an ecosystem healthy and functional. I mentioned all these different ecosystem services that the accumulation of soil and soil organic matter provides. Things like biodiversity, water purification, nutrient cycling. These are all things that depend on functional, healthy soil. Another thing we talked about was that land use change from forest to agriculture can cause significant carbon loss. And that's why carbon needs to be top of mind when we're thinking about where and what agriculture looks like in northern environments. We're starting to understand and develop ways to reduce this carbon loss or put carbon back into the soil after it's lost, but there's still so many questions and so much research and work that needs to be done in conjunction with the people that live up here. And this just ties into the fact that we need specific soil amendments targeted to the unique environment and cultures of the Northwest Territories and the Boreal Forest region in general. So I'm just going to end this presentation by talking about how wildfire plays into this story. So like I mentioned earlier, in 2023, the Northwest Territories and a lot of places in Canada had their worst wildfire season ever. And wildfire brings with it so much anxiety and uncertainty and unanswered questions. It's hard to completely understand the impact that this has on the communities and the cultures, let alone the environments and the soils. And this theme of unanswered questions is definitely something we're going to think about more when we're thinking about how wildfire impacts the agriculture suitability of northern soils. Wildfire is inherently a complex ecological process involving all kinds of different factors, different environmental, ecological, hydrological factors. But for the purpose of the next few slides, I'm going to really oversimplify the impact of wildfire on soil carbon and soil fertility by just treating it as two different groups: high severity and high frequency fires, or low severity and low frequency fires. So let's start by talking about high severity or high frequency fires. So these are fires that burn deep, they burn hot, they burn for a long period of time. And when this happens, a lot of that important organic material that I mentioned was present in the soil can all or mostly all be depleted. And when this gets depleted, this means the nutrients and the components of the soil that support agriculture suitability are also depleted, and soil fertility is depleted. So in these high severity or more frequent fires, it means the fertility of the soil can be greatly reduced or almost eradicated. And the story kind of holds true for soil carbon as well. So in these high severity or high frequency fires, we're going to see a lot of this organic layer be depleted. And like I mentioned, the organic material of soil is typically about 50% carbon. So when we're losing the organic material, we're inherently losing carbon that's moving from those soils into the atmosphere. But the story has the potential to be slightly different when we look at low severity or less frequent fires. So these are fires that may not burn as hot, they may not burn as deep, they may not burn for as long of a time, and this can lead to kind of incomplete combustion of that organic layer of the soil. So not all of that organic material is burned, or it's not completely burned. And in this case, we can actually see instances of a nutrient boost or increased productivity of crops in these fire-prone areas that experience low severity fires. And fires are inherently a natural process. So historically, they can't always completely decimate the landscape. There is potential for this nutrient or fertility boost. And this happens as a result of a variety of processes, from nutrient-rich ash deposition to sometimes nutrients being tied up in the soil or inaccessible to plants or crops. Fire can sometimes allow these nutrients to be released or accessible to crops or vegetation so that they can use them more readily. But it's important to note that these nutrient boosts are often relatively short-term. It could be 1 year, 3 years, 10 years, but systems have a tendency to fall back into an equilibrium in these cases, so these nutrient boosts are not forever. And we can see a similar kind of story when it comes to low severity or less frequent fires, when it comes to the impact on soil organic carbon. So, like I mentioned, the entire organic layer isn't always depleted. If there's this incomplete combustion where things are charred but not burned, it can form what's known as biochar. So biochar is a pretty buzzy word. It's in a lot of news stories, it's in a lot of articles as this soil amendment that improves the fertility of soils. But biochar also has this function as a stable form of carbon. So when we talk about carbon leaving the soil and moving to the atmosphere, that's inherently because of a process called decomposition. So when microbes start to eat the carbon that's in the soil, it gets released from the soil as carbon dioxide into the atmosphere. When the carbon becomes biochar, it makes it a lot harder for microbes to access that carbon, and as a result, it is able to sit in the soil for hundreds to thousands of years as this stable form of carbon. So some important questions going forward are, how much of this carbon is remaining in the soil as a stable form? How can we identify areas of low severity versus high severity? And can we use some of this naturally occurring biochar as a soil amendment technique? So fire is complex, and its impact on agriculture, agriculture suitability, soil fertility, and soil carbon, it can all be a lot to think about. And then when you start to factor in things like hydrology, topography, what the land looks like, all these different factors influence what the soil looks like before and after it's burned, and what the response will be like in terms of the agriculture suitability of these soils. But there's a lot of really amazing researchers thinking about how do we explore the big questions related to agriculture and wildfire and soil going forward. So questions like, can we identify suitable areas for food production post-wildfire? Or can we use partially burned soils as an amendment, like in the form of biochar? Or what management practices help replenish lost nutrients and carbon post-wildfire? These are these management practices that will be targeted to the north, or these ecosystems that are prone to fire. Or finally, how do we make food production systems resilient to wildfire in general? These are just some of the many questions that a lot of great researchers are thinking about when exploring next steps as to what soil research looks like in the Northwest Territories or in the Boreal Forest in general. So as we wrap up, I just wanted to bring you back to our Group 1s and our Group 2s. So hopefully, with the talk of wildfire, the importance of soil and agriculture, I have shifted at least one of you from a Group 2 to a Group 1, maybe more. But hopefully you can at least take away some interesting facts about soil that'll make you think about soil more often in your day-to-day life. And hopefully I haven't created any Group 3s, and if I have, I'm really sorry that you're upset, and I hope the rest of your day can be a lot better, and I haven't wasted half an hour of your life. But with that, I just want to thank you all for watching, and I especially want to thank the communities of Kakisa and Enterprise who allowed me to come onto their land and collect my soil and answer my questions, and who I learned so much from over the last 6 or 7 years. Thank you.